No, no, I'm okay. The agenda. On the DappCon website. Yeah. Cool. So welcome everyone. This is the QR code to scan to enter the Telegram group. We will have some docs link there for the tasks that we will do in the second part. So how this workshop is structured is that for the first part, we will go through some basic DeFi concepts. And for the part 2, we will actually do a couple of tasks to execute the DeFi transactions. So the vision of ENSO is to be a unified network to access blockchain and DeFi protocols. We started 5 years ago, and we noticed straight away how hard it was to build on blockchain networks. It meant to integrate multiple DeFi protocols, and for every protocol you had to deploy a smart contract. Not only that, but for every single protocol lived also in different chains, so you need to take care of the deployment on the script, on the maintenance of all that part. We released the DeFi aggregator, and soon other applications started to ask us access to these protocols. So that's where the modern ENSO started as an API. So developer tool where you integrate one single tool and you can access all the DeFi protocol actions and on every chain. This is our core product offering. So we have the execute part. So basically the API provides you the call data and the best route for swaps, DeFi action, which is borrowing, lending. We recently releasing, is not public yet, but is in the docs, so you can check it out. We released a flash loan aggregator, and it's basically used by lending markets to create looping positions, and the bridging aggregator. For the data part, we offer APY data, TVL data, the prices, and all of this through it's basically abstract to create a earned product. So the full suite to build your own earned product. We support basically all the DeFi protocol, I think around 100. On top of this, everything is simulated, which is, we will go through later, is quite important in a blockchain transaction that you simulate what third party returns, because you know, like you never know what the call data does. So you need to be sure that the transaction that the user will execute does exactly what you expect. These are some numbers. We have a lot of companies using us. In the last 5 years, we've settled around 20 billions in volume, with the biggest 3-day streak that was for the Bera chain launch, Boico with layer 0 was 3.1 billions into 80 DeFi pools in the same day, 3 days. We have 13 audits, as you can imagine, was very expensive. And we have some open source tooling that it's quite cool. You can check it out in our GitHub. Temper is a transaction simulator, basically Tenderly, but open source. And the Wayroll, which is our core contract, which is a smart contract virtual machine to chain transactions. So to start, we will go through, like, how many of you know what is a DEX aggregator? Okay, I guess mostly everyone. The general idea on how it works, and then I will go through how we use it inside our DeFi toolkit, is that a DEX aggregator is basically a graph. People put all the pools, index the pools, put it into a graph, and then run pathfinder algorithms to find the best path from token A to token B. There are multiple tricks, you split the route and so forth, but this is the core concept. There is a layer on top. This is how we do for swap aggregation, which is called meta aggregator. There are some UIs nowadays that offer this. I think the first one was DeFi Llama and OkuTrade, MetaMatcha, things like that. Our API basically meta aggregate every single DEX aggregator, and there are a couple of reasons to do that. One, some aggregators are better than others. Some support RFQs, some supports liquidity sources that others doesn't, and some are better optimized for bigger trades or small trades, and they have all different gas costs depending on the operation that they chain. This increases the execution reliability. And the most important part is that very often DEX aggregators overquote, which means that they promise you to return a certain amount, but in reality, on-chain, this is not true. And there is always some sort of delta from what is quoted versus what is executed. This is why we added a layer on top of this meta aggregation, which is quote simulator. So we perform simulation on every response of the DEX aggregator. Then we basically sort to the real amount out, and we pick the best one that for the real amount that they return, not what they quoted. We recently released the dashboard for this. Is basically showing who are the best and who are the worst. So the overall idea is basically who simulate their transaction before returning to the users. If I put it like, wait, let me put it on Telegram. If you want to see it, it's in the Telegram group and shield.tenso.build. For example, 0x is always one of the ones who simulate the transaction. We also illustrate the latency. And yeah, this is the overall. You can see sometimes quite big numbers. Sometimes we got even 100% because some DEX aggregator were putting a fee without basically saying it to the user. We generally also work with DEX aggregator. Like if we see some numbers that are too big, we try to reach out and say to check certain routes and paths. But this, I think, is an essential tool for everyone who wants to trade on chain and want to perform DeFi actions for the user, is that the aggregation part need to be correctly simulated. Otherwise, you can have a huge revert rate or basically misleading the user. If you want to check it out, the website, we also have some other performance charts, the overquote rate, the simulation rate, the latency comparison, and some outliners, like in the last 7 days. Like, for example, big transaction simulated was almost 1 million, and the delta is basically 51K. This is a lab test. So we basically take the call data and simulate it against the latest block, which cover most of the cases. Here you can see some other illustration for it. Why the DEX aggregator do that is a mix of reasons. Sometimes they just use a pure mathematical approach. So everything is pure computation, and they don't find the best path by simulating. Sometimes it's basically they just want more order flow. So in competition, if the meta aggregator doesn't check this, they basically win order flow. And in general, they don't simulate the transaction. There is another reason that came up lately in the last months, which is like toxic pools. A lot of malicious pools came up, especially in protocols that allow to create pools with custom behaviors, like Uniswap hooks and curve pool. Basically, these pools are done in a way that tricks transaction simulator. So generally, when people do simulation, do a ETH call, and they don't set a gas price, for example, or a Coinbase account, or a timestamp, And this pool put in Solidity logic certain checks that tricks the simulator and basically try to scrape as much as possible the slippage from the user. This is an example of us. Yeah.
Can you explain how they do that?
Yeah. So.
Or like one example?
Yeah. This is an example. Well, I don't have the code here, but I can show you later the code, but I can summarize it now. This is a toxic pool that was on Curve. In the last 2 weeks, basically made 120 million volume and stole 60K in fees. Generally, when you do a simulation, you do an ETH call, right? And it's like taking the call data and you say, okay, simulate the latest block, and you extract the amount out that this transaction will give to the user. The issue is that out of the box, this simulation don't consider a lot of things that are actually unset on chain, like the gas price. So some of these pools were encoding in the Solidity logic. If the gas price is measured than 10, then apply a fee. So the simulator, because they don't set a gas price, was strict, and the fee was not counted in. This is a... Sorry? Is it not possible to simulate? Yeah, exactly, yeah. I mean, this is like how we kind of solve it. Is like the feature that we added lately is not only gas price, like these malicious attacks are like, they change every day. But one of the latest features that we add is toxic flow detection, which is basically we don't just simulate purely, but we start to do state overrides on the request, overwriting the block, overwriting the gas price, the Coinbase account, the timestamp. Because this was just an example, the toxic flow detection, but there are some other things like fee based on timestamp. So basically, if you make a transaction, if you get a request, you simulate it, looks good, because you simulated at this timestamp. But in the Solidity logic, you can say, if 10 seconds passed, then apply a fee. So in that case, you need to kind of start to spam with simulation with different future scenarios to understand and detect if there is some sort of toxic behavior or hidden fee. Yeah, this was just an example of a pool in the last 2 weeks, but we've seen many on Uniswap hooks, and it's very hard, I have to say, for an aggregator to catch all these malicious pools, because it can really be anything encoded in Solidity. We generally report these pools to aggregator, and they are quite fast on removing it. But since we cannot trust always these responses, that's why we added base toxic flow detection and hidden fee detections. This is also one of the main features of Enso, that is a standalone tool. So you basically can call it with whatever. If you have a DEX aggregator on your app and you want to verify that the behavior is correct, you can call the Enso quarter, and it will automatically top up the balance of the user. So to simulate, you don't need that the user has the balance. It can just, we automatically top up in the simulation environment the balance of the user. You can do batch quoting and yeah, the feature that we talked about before. It's also very, very fast. So it's probably like 200 milliseconds, and you can batch simulate 10 different DEX aggregator responses, so you can pick the best one. Okay, so I think that's it for the first part. Is there any question?
These toxic pools, who's doing those? Is it like MVP kind of actors, or?
Yeah, I mean, malicious actors. Yeah.
They deploy their own funds.
Yes. Yeah.
And you don't need a large capital, essentially, because you trick the oracle, either in the hooks or curve rate oracle. So yeah, it doesn't require large capital. It's just manipulating, in a sense, that oracle returns higher price than market average. DEX aggregators choose that pool, and then during execution you get caught.
Right. And do you have approximate numbers, like over months, how much
No, not yet. I mean, it's something that I wanted to look into, especially because lately the number of toxic pool increased a lot. We started to see a lot of failed transaction on all the meta aggregators. And it was mainly what we seen was Uniswap hooks and curve pools. It will be nice to run some analytics on this. Yeah. I think we will something that we will do in the future. Cool. So the second part, it's more hands-on, and it's about building a earn product. It will use the Enso API to create the basis, so getting the user balance, the data, so of the DeFi position, so APY and TVL, the route actions, so you can do swaps and DeFi deposit and a single chain on different chains. Access RWA, we are minter for Xtox and Ondo, and soon a couple of other RWA providers, and in general DeFi actions. Sorry, we started 15 minutes ago because there was a time change. So in general, there are two different types of DeFi positions. The simple one are tokenized DeFi positions, which means what probably protocols that you know already, like Aave, Pendle, everything that gives you a ERC20 receipt. And this is it's all available in the route endpoint, because this being a tokenized position, you can use routing, which means DEX aggregator plus a DeFi hook to enter a specific position. There are some other more advanced type of positions which are non-tokenized, which means opening a borrowing position, open an NFT position, deposit without any ERC20 receipt, a sync vault, for example, like vaults that either don't allow everyone to deposit, so you kind of make the request, and then in a second moment they will send you the ERC20. For example, Open Call, it's a insurance wrapper for vaults. In that case, you request a deposit, you stake your request, and they will send it to you. And all these actions are composable with the bundle endpoint. So, since few people joined, I think the time on the agenda was wrong. We started 15 minutes ago. If you want to join now that we will do the task, this is the Telegram group. Okay, this is the first task. It's pretty simple. Just get used to the API. In the Telegram group, there are the docs links, and it's basically to create a simple DeFi route Ethereum into a lending pool, in this case Aave. I think we will leave like 5-10 minutes for you to play around, and then we will show it into the screen here. Is there any question?
Can you give us a QR code again?
Yeah. Can you see the messages on Telegram?
No.
Oh, okay.
No,
And I will link the dashboard that we talked about in the first section on comparing DEX aggregator. For the people who join now, just to give a quick recap, we went through how a DEX aggregator work, why you need meta-aggregation, which is basically you cannot trust DAX aggregator and you need to simulate what they actually return for a various reason. Can be like just miscalculation or they want to get more order flow. We release a dashboard that is testing all the DEX aggregators that is linked in the Telegram chat. And we also talked about toxic pool that a lot of these DEX aggregators are vulnerable to, which means pools that try to fix with solidity logic simulations. And yeah, this is an example of the last 2 weeks. A pool stole 60K in fees from DEX aggregator routes. And because of this, it's not announced yet, but we released it since a week. We added toxic flow detection. So when you simulate with our simulator, you get the actual return that is already counting in the toxic pools fees. I will go back to the task. And if something is not working, just call us and we will come there to check. I posted in the chat in the Telegram group the endpoint for that request, and now we'll add the token address in case you didn't find it.
I'll put it in.
Sorry?
I'll put it in.
Okay. Okay, I think we can move on. Brandon's will show now basically the task from a terminal, just to inspect the response, and we can see how the first part, the meta aggregation, is used with the Aave DeFi hook.
Yeah. And should I use the mic? Yes. Yeah. Okay. So what do you see on the screen is essentially the request for...
Sorry, can you zoom a bit? Maybe, I don't know if the streaming, yeah. Okay, perfect.
Sounds right, yeah. Yeah, essentially the request to route from Ether to Aave's AUSDT on Aave v3. I can just simply go through each line, amount in, which is in wave value, which is 1 Ether in this case. Token in, we represent it as the quote-unquote native address. Token out is the AUSDT. Slippage can be set, cannot be set. Default is 50 that we always set for every route. From address is the address who is going to execute the route. Receiver is also optional. You can specify if receiver. If you want the funds to land in a different address, usually it's never the case. It's always the same address. Chain ID 1, which is the mainnet, and then I'm passing the API key. And then, yeah, this is the response, which returns the call data together with gas, amount out, the price impact of the route, just to ensure that unexpectedly the value that you receive is not significantly less than you inputted. And the whole transaction object that user executes. And then the interesting part is the route, where essentially you can see 2 different hops. The first one is the swap from Ether to the underlying of USDT, which is USDT, which is the USDT. And then we take the whole amount that was produced by the swap and put it into an Aave USDT. That's it.
Yeah, so the first part is basically what we've seen before with the meta aggregation. In this case, a northern one. The transaction was simulated, and then there is this DeFi hook. You can go. The DeFi hook, which basically is saying, take the amount out that was returned from the swap action, and basically deposit into the Aave lending market.
Yeah, and if you're interested, that's the Enso Vero that Milos previously mentioned, which is open sourced. You can check it out on our GitHub.
The call data you can of course like double verify if what we return is correct. A lot of people like to use Tenderly for having the full UI to simulate. Our type of simulation is a bit different. It's more like very specific and meant to be very fast. But for like inspection of the full route as code, I can recommend Tenderly UI. Okay, is there any question on this part? If not, I will move to the second task. I'm assuming everyone will use cloud code, so it's more like a prompt that rather than a task. Second. Yeah. Okay. So the task 2 is more like to show the end-to-end of an earned product, how it could look like. We have multiple endpoints for this. I linked it in the Telegram group, which is this one. So basically, the task is to create a small UI where the user can connect with MetaMask or Rabbi. You can use the balance endpoint to show the user balances, which it's already organized by DeFi protocols. So you can see, like, when you get to the endpoint we will leave 5-10 minutes for the task for you to play around. Then we will show it on the screen. It basically organizes everything by DeFi protocol. So if you have another position or you have a pendle position, you will see it there. The second part of the task is to display basically a box where you can show the APY and TVL of the DeFi position. And the third one is to actually use the one that we used before, so the route, to allow the user that is connected to actually execute this transaction. If you want to test on a cheaper network, we support Aave on every network, so you can just pick Base instead of Ethereum. Yeah, that's it. I will leave 5-10 minutes, and then we will go through again with code and some UI example here. And again, if you have any question, you can just reach out. Yeah, is the protocols endpoint. Maybe I can show you. Yeah, we have Swagger is linked into the Telegram chat. So we have a bunch of protocols. Maybe meanwhile I can go through. A bunch of routes, endpoints. The basic one is the route, the part that I mentioned before about simple tokenized positions like RC20. The non-tokenized route, which means NFTs and all the sort of position that don't return a receipt token. The bundle endpoint, sorry?
No, I wanted to say best example would be Morpho in that case, for non-tokenized.
Yeah, definitely. And the bundle endpoint, this is meant to use declarative DeFi actions. So swap plus deposit plus borrow. If you want to do it in a certain way or orchestrate your own flow, you will use this endpoint. Going back to the question, there are like all the metadata endpoints. So the network that are supported, the prices, the tokens, the non-tokenized positions, and the protocols. So you can see for chain ID 1, I think you should return all the list of protocols that we return. Yeah. Xtox, and also the chain where these protocols live. So Xtox, Yearn, Orderly, Pendle. There are quite a lot. I mean, it's like most of them now they have 0 TVL, but are still supported. Yeah. Yeah. Both for swaps. And I think also to deposit into the LP pools. Do we have deposit into? Yeah, we have our own DEX aggregator, but generally the swap part is managed by the routing.
Yeah, in the Fluid, we don't have the LPs, we have the deposits in for the lending part.
No, we do have looping. Yeah,
Looping as well, yeah.
No, we don't have the LP tokens of the DEX, but we have the lending market. the looping, you can achieve it by doing a flash loan into another protocol, like Morpho. Yeah, we have also a bunch of other endpoints, but these are for the cross-chain part. So to track the transaction with relay, layer 0, CCIP, CCTP.
Also, if you're in the Telegram group, I put the link. How would you get all the fluid lending receipt tokens, essentially, where you can route? I put it in the Telegram group, the link where you could see a list of all the assets that you can route into that are related to fluid lending.
Is a .build. Wait. Here you can create the API key. It generally works also without API key, but yeah, of course there are like limits for that. You can also use this one, it's disposable. Okay, do you want to show how it works for these endpoints?
Yeah.
Oh, sorry.
Which one?
This one. I think you need to press somewhere. Yeah.
Yeah, so what I'm showing is an endpoint that you can use to fetch user balances or any other balance, and it will return you a list of the balance on the same chain, on the chain that you specified, sorry. And then you can find if user has DeFi tokens, you can then fetch the tokens endpoint. This endpoint can be used to fetch the metadata of the tokens that we support, that can be routed to, which essentially should also include the Aave USDT one that I showed before. The metadata, if a token is a yield-earning asset, you'll have additional data like APY, TVL, that you can use to display to the user, help them understand what is the state of the asset. And you will see that, yeah, currently I'm just fetching the Aave v3 assets. That is like a type DeFi. That's how we identify assets that are require special actions. In this case, it would be a deposit into Aave v3. The other type we have is base, which we just do a simple swap into via DEX aggregators. Is there anything else I missed?
No, that's fine. Let me plug it. Yeah, I can show here the a more visual example. So this is basically doing the same thing that the task2 was doing. Basically, you can get the protocol list. These are all the protocols supported on Ethereum. Spectra, Pendle, Aave, and so forth. We can check Aave, and we can select Aave v3. So 2% APY, 700 million TVL, and we can see the visual part, which was like the same of the terminal. There is a swap and the DeFi hook into the Aave v3 pool. Cool. Is there any question for the last part? Okay, so to conclude, these were basically mostly the, sorry, it's lagging a bit the computer. I think. Oops. It's really stuck. So. It's really stuck, so okay. Let me see. Sorry, there is quite some delay, I think, because I connected the, I need to buy a new Mac. Okay, yeah. So all of this was the first, the simple part, which was the tokenized position, so the simple DeFi tokens, the receipt. For the more complex part, you will need to use the bundle endpoint or the non-tokenized endpoint. I'm trying to get to the right slide. Okay. Hopefully it stays like this. Okay. For the advanced use cases, generally we do support it into the non-tokenized endpoint, where you can pass a position ID that represent the NFT, for example, or other abstracted parts. Otherwise, we have the bundle endpoint where you can be more declarative. So you can say, first do a cross-chain transaction, and in the callback of the cross-chain transaction, you swap and deposit into a token. Or certain stablecoin uses this endpoint for abstracting the chain. They usually have a minting contract on Ethereum, and they want to have the user just to, come from the whatever chain, click deposit, and receive on a certain chain. So what we do in this case with the bundle endpoint, you can construct the route saying, I will bridge the stablecoin, the USDC, for example, mint the stablecoin, and then in the same transaction, send back to the original chain the stablecoin. This is because stablecoin issuer often prefers to have the liquidity and the minting system on a specific chain, but still want to be composable with the DeFi protocol on, for example, Optimism on Hyper EVM. So in this, using the bundle endpoint, you can construct a more complex iteration and basically create abstraction. We will release probably next week sorry, you want to say something?
I just wanted to add to the bundle endpoint. It's a place where you can express yourself in a low-level way, even if we don't have any some actions from some sort of protocols. You can do low-level calls to the contracts that you wish to combine them, take the outputs from those low-level calls to other inputs. It's a great tool if you want to express yourself in a certain way for a specific route that may require more logic than just a simple token A, token B. And yeah, as Miloš mentioned, that one of the principles is the double bridging, how I call it. And the other one that recently came quite common is the flash loan looping.
Yeah, and the bundle endpoint, I'm trying to, the computer restarted. The bundle endpoint, it's having the same security measures as the other endpoints. So basically all the transaction simulator and the outcomes are used to write on chain the minimum amounts. So you don't risk that your transaction get front run or MIV attacks. And of course, there is also all the simulation part of to skip toxic pool or fake quotes from DEX aggregators. Yeah, I think that's it. Do you have any question? Cool. So thanks everyone for joining.
Oh, there we go. Okay, nice. Hey, come on in. My name's Dave, DMC. We've made something really exciting I'd like to show you, and we can play with it a bit as well if you'd like to engage, or I can also just demo it. We've got an hour and a half, but I wanted to take a little bit at the top to break down what this is, because it requires a paradigm shift. It requires grokking that this is a different way to build. This is a different way to solve. The headline is, no servers, no cloud, no masters. Build peer-to-peer apps. So 4 years ago, we started working on a concept, which is, can we build peer-to-peer applications and systems that require no server infrastructure? And it turns out that you can. We've built an app called Keat on top of Pair. Pair is the thing that allows you to build peer-to-peer apps. Keat has 1 million new users per month. It scales to the planet, and the infrastructure cost is essentially 0. Compare that to Telegram with a infrastructure cost of 700 million a year, and you can see why this is a good idea just on practical grounds. We can build applications that currently exist. We can build new types of applications that aren't even possible with a centralized approach, that are real-time, that work almost identically to their equivalent apps, but with no infrastructure cost. Imagine you're saving 700 million a year on infrastructure cost. Where are you going to put that, right? It goes to things like business strategy, marketing, compliance checks, all that kind of stuff. So it also eliminates a huge amount of communication, because when you have infrastructure, that requires people to oversee that infrastructure, and that requires many layers of communication around that. You eliminate all of that, you eliminate a lot of noise within an application's development and deployment. You eliminate that, and you can, with say 4 friends, make an app that can do something at much higher scale than you could have before. If you can build a UI, and you can think a little bit in the peer-to-peer paradigm, you can build things that don't have any infrastructure cost. If you don't have any infrastructure cost, you don't need to exploit your users by their data, because you're basically taking a fire hose of user data exploitation, and then you're sending that fire hose straight through to pay cloud providers. So with this, you don't have to do that, and just on a basic human level, that feels right. Here's how it works. Use a module, deploy peer-to-peer, no cloud involved. That's it. We have a module, you take it, you put it into your project. It enables peer-to-peer over-the-air updates on desktop, on terminal, and coming very soon on mobile as well. So that means that you can deliver your application via the normal channels, but then any updates to that application come through as peer-to-peer updates. So you can deploy an application to billions of people around the world with no servers and have peer-to-peer over-the-air updates. Today, this is open source and available, and it's how we build. This is Keat. The beginning of this year, we had an uptick in usage, and whenever there's difficulties and challenges in a particular country, and they start locking down communication and locking down internet access and different things, we see a big rise in that country of usage of Keat. We've not been marketing it, we've not really been advertising it, but as I said, we have 1 million new users a month currently, and growing.
Sorry, what are the two?
Oh, sorry about the confusion, yeah. That one's velocity, I think, but look at the green line. I need to get a better graph. So, pairs.com, peer-to-peer embedded application releases stack. If you'd like, you can scan that. It might still work. If not, I can sort you out later. But we can connect on Keat, and you can come into the pair development room. You might need Keat on your phone first. I don't think I've updated that QR code. It'll be on the bottom left of the screen. You might not be able to scan it, but don't worry. There's not that many of us in here. We can figure it out between us. The stack. We have a library called pair runtime. You npm install that. This is a JavaScript thing right now. But the paradigms and the protocols apply to anything. The command line interface is pair. You use that to deploy your application. You can also use it to install applications peer-to-peer on desktop. Then bear. Yes, we have pair and we have bear. The logo for bear is a bear, but it's not spelt that way. It's spelt in terms of bare metal. And the reason it's called that is it's a Node.js-like JavaScript runtime with no core library as a very specific design choice. If you have no core library, then you're not granting any capabilities from the outset. If you have no core library, then it turns out getting mobile support is much easier. So we run anything that you need native-wise with Bear, you just install it as a dependency. So if you need to use the file system in Node, you use the core FS module. With Bear, you use the Bear FS module when you install it. With that, it works on mobile, on desktop, terminal. We can deploy a single peer-to-peer backend on Bear, on mobile, desktop, terminal, and then the whatever view layer is, so say it's React Native on mobile and Electron on desktop, that can talk to the same code that runs in the Bear backend on that machine. So this is really nice, we found, as an architectural choice, because most people are used to the front-end, back-end paradigm. So we just say, OK, well, there is a back-end, but it's local on device. You talk to it over RPC, and then that local back-end does all of the peer-to-peer magic. Then there's the Bear module ecosystem, and then there's the Hyper module ecosystem, which is where we get all of the peer-to-peer capabilities. There's about, I think, like 2,000 modules on the whole Punch GitHub repo that this all extends down into. This all comes under the stack. I've said some of this already. We can skip it. The pair runtime module, the only thing I'll say is it has a run method, and that's for encouraging this architectural approach I'm talking about. You can npm install pair runtime and then use pair run within an Electron app or a mobile app, and it will start a Bear worker, which is your peer-to-peer backend. This is the workflow overall. I'm just giving you an overall image of this, and then we're actually going to go through a little workshop and play with the tooling, but this is the full picture. You use pair touch to create a pair link. That's basically a deployment target. You use pair seed to expose hypercores to peers. So the way that it works is it's next generation BitTorrent called Kademlia, and that's seeded over a DHT. And then a topic, the pair link is actually a topic, which is then discovered via the DHT. So when an application connects to the seeded hypercore, it's connecting by the pair link key, which is a topic on the DHT, which allows peers to find each other. There's pair build, which creates a multi-arc deployment folder. So you've got Linux, Windows, Mac. You put those all in one multi-arc folder, and then that's what you actually deploy. pair stage synchronizes the files on your disk into a hypercore. That's the equivalent of the staging environment. So when you stage, you're actually at the point. In the workshop, we're only going to take it as far as stage because that just shows the functionality. But when you stage, you're actually at the point of doing peer-to-peer deployment. Because by synchronizing from disk into hypercore and seeding that to the network, you're exposing the builds. Your user installs the build. It connects to that to you as a peer, and when you stage the next time and you do an update, the length of the hypercore increases, and then that is replicated to the peers. The peers receive that as an update event, and then they can click a button and it applies the update, does a swap on disk. That's how it works. Pair provision, sorry, I wasn't sure if it's a question, but there's a yawn. It's all good. Pair provision is a pre-release step, and it basically strips down the hypercore. Because every time you stage, if it's doing a deletion, then that's actually an append. So when you're staging to a hypercore, it kind of gets bigger and bigger and bigger. But when you do a provision, it strips out all the intermediate steps, and it's basically like a snapshot block sync, right? So that becomes a pre-production drive. That link, that pair link, you give to like QA teams, and that's when you're getting really, really serious. Like, we're about to go into production. This is how we make Keat. And then there's pair multisig, and that's the production step. With pair multisig, you have this pre-release key, this pre-release pair link that you've been QAing and all of that, and then you have stakeholders who are responsible for what's going out. So say you've got like 5 stakeholders, and then 3 out of 5 have to sign in order for that to actually hit production. So all of your users are using the multisig production link in their application, and the 3 out of the 5, say, if it's 3 out of 5 quorum, who sign, each one of those people who sign are saying, I'm putting my career on the line to say there are no supply chain attacks, the diffs look good, I don't see any bugs, I don't see any vulnerabilities, right? It's a very thorough process that is then signed off cryptographically with your public key, and people know that that's your public key. We've developed that process over the years because doing a peer-to-peer deployment, it's really, really important that it's done right and that it's done seriously. And the pair multisig command really hones the focus. So that's the full flow of how you deploy a pair app. It works like this. You have this dual distribution. So you do your builds like you normally would. You build your mobile app, you build your desktop app, whatever. You put it on a website, you put it in the App Store. The user gets it, they start running it, and then it connects peer-to-peer. From there, it's peer-to-peer updates. We've talked about Bear, so I'm going to skip this. This is the Bear ecosystem. I don't know if you guys have used Node or whatever, but the things in green are basically the equivalents of Node Core, and then there's a bunch of stuff beyond that as well, like Bear FFmpeg, which we use in Keat for certain things. Then there's the Hyper ecosystem. You have the Bedrock primitives. I've already mentioned Hypercore. You also have Hyper DHT, which is peer discovery, and then you have Hyper Swarm, which is peer discovery via topic. Then you've got the data structures, Hyper-B, Hyperdrive, and Autobase. Hyper-B is a key value store. Hyperdrive is a peer-to-peer file system, and Autobase allows you to do multi-writer. The really cool thing about Autobase, and this is what we use in Keat for conflict resolution of messages, is it has this apply function. So if you're on Keat and you're talking to someone else, you and that person both have an append-only log. I write a message, it appends to my append-only log, and then you receive that message, it appends to your append-only log, right? But it goes through this linearization process via Autobase. So the Autobase runs that through an apply function, and the apply function determines whether it's written and how it's written and when. And with that, what you actually have is tokenless smart contracts. Just something to think about. Storage and sync. Core store is for managing multiple hypercores. Local drive is the equivalent of hyperdrive, but for disk. That's how we do a stage. We just have a local drive that mirrors to a hyperdrive, which is what we use mirror drive for. So like I said, you have these deployment layers. You have this build flow. You have a deployment directory, which is your multi-arc folder. And then you have the staging layer, which you can just pair stage to. You can have a shared staging key. You could also just touch a new link, stage to that, give it to a colleague and say, hey, can you just check this over? Or like, I'm struggling with this or whatever. It's really, really easy to create variations internally that no one else ever looks at, even internally, just between you and someone else. But then you can also have, like, these are the official links between us. So we have a development stage key, we have a staging stage key, and we have a release candidate stage key. And it goes, that's an additional process that we have where we're going through each stage until once we get to the RC key, it stays on there for a couple of weeks, and then once we're like happy with it, we do a provision and we create the pre-release key. The pre-release key is like I said, a very, very serious moment. Like at that point, we have QA check the RC, but then QA check the pre-release key as well. If there's any problems with that, there shouldn't be any problems at that point, because what you're saying with the pre-release key is like, if we'd have gone to production today right now, this would be it, right? And then once that's been verified again, then you do the multi-sig and you go into production. This is just a release cycle. Every time we're going to look at the hello per electron boilerplate. But basically, every time you bump the version, that's to create a new build, and the updates are based on the version increasing. So you version it, you make the distributables, you build the deployment directory, you stage, you provision, you prepare the request, you sign, you verify. Once you've got the signatures, you commit, you're in production. So we've got different quick start guides. The one we're going to be looking at is the Electron boilerplate. Don't worry, we'll come back to this. We also have a bare boilerplate, which is for creating peer-to-peer terminal applications. So CLIs, REPLs, daemons, services, hooks, whatever you can make in the terminal, you can now make as a application that has peer-to-peer over-the-air updates. PairPass is a product that we've made, which is a password manager. You can't leak clear text passwords if the thing doesn't have a server. Like, you eliminate all of that, and you just have it between your devices. It's about personal data custody, right? QVAC is a local LLM project. There's a lot of optimization for running LLMs locally. This has a really nice parity with our peer-to-peer stack. One of the things that QVAC can do is remote inference. So if you have a nice beefy machine with some LLMs on it, you can use QVAC with our stack and use it on phone for like the easy stuff, and then offload compute for the remote inference. And of course, that's all completely private, and it's all completely your machines, your data. And then, of course, Keat. And like I said, we've discussed that. If anyone wants to connect with me on Keat, we can later on. Same for that. There's a news, pairs.com news, check that out. docs.pairs.com to learn how to build. And careers.tether.io, because we are hiring, like, actually a lot. We need people of all kinds, front-enders, back-enders, cryptographers, whatever you are, we're probably hiring. So have a chat with me if you're interested in that. I certainly would be interested in that. So any questions before we get into the workshop? Yo.
Thanks. I really like what you guys are building. I've been following since the beginning. of everything that.
Using the mic.
Yes. Thank you. There's one thing that might be a stupid question based on what you just described, but I'm building an app that has quite a few users at the moment, but in order to make it as accessible as possible to the general public, it's a web app.
Sure.
It's a web app. We try to keep everything local on your browser, and when you need, you sync with end-to-end encryption, etc. Are you thinking of introducing anything in your tech that could be applied to web apps like mine that try to maintain the best security and privacy as they can?
Yeah, so that question has been asked many times, and the answer is unfortunately always the same. Browsers are controlled by specs. Specs are controlled by organizations who have a vested interest in remaining centralized. In order to do the kind of peer-to-peer that we do, you need UDP. Browsers don't have UDP. I don't expect they will ever have UDP. It's not a technical problem, it's a political problem. So our response to that is to go 100% on apps. However, you can just, like I said, you can create like a bare process with like OTA updates or whatever. So you could create a server that's a portal into a peer-to-peer landscape and then progressively enhance from there. So you can have a web app that gives your users as much as you can give them, and then after a certain point, when you have the scaling need or whatever that feature is, then you onboard them to the app, which is a pretty normal flow. And we haven't decided to do that for us because Keat is a messaging app, and it doesn't necessarily make quite as much sense as a web app then. But I do think that there's other types of apps that you might build where you're going to want a portal probably.
Super, thank you. And last question. So we're indeed also preparing some desktop and mobile apps. So slowly taking the users into something that's much higher friction. But for us, it's document collaboration, spreadsheet collaboration. So you have 100 people editing the same stuff. You need CRDTs, etc. Do you think that at the moment what you've built is already at a good stage to handle applications that require, I don't know, 1,000 edits per 10 seconds by so many sources?
100%. 100%. Not that it's easy, but the key is that every edit needs to be you don't store the latest state, you store every edit that's made. And if you do that, then you've got undo and redo and all that built in. But you're taking advantage of the append-only log. And then the auto-base apply, you would need auto-base for this, for sure. And then the auto-base apply function would then be deciding who wins, or it might even have, you can do it any way you want. You can even do it for certain situations where it sends it back to the user and it makes the user decide who wins, right? But there's many ways you can do that part. As long as you're not trying to store latest state, as long as you're actually storing every single edit, then 100%.
Thanks.
Sure. Any other questions? Yeah. I mean, yeah.
Wait, I'm coming.
Oh. Thank you.
Thank you. So, yeah, super interesting, first of all. Who's running the DHT server nodes? Maybe.
So every peer can be a Bootstrap node, but you need the IP addresses of the Bootstrap nodes. So the Keat app, for instance, has a couple of Bootstrap nodes hard-coded, and we run those, right? But if you're making your own app, you can set up your own Bootstrap nodes and run them.
And
or you could make it so that your users could supply.
Would these networks then, or these DHTs overlap? Is it like one giant DHT where all the apps would register themselves, or does each app have their own?
By default, the first, but if you'd like to customize the second.
Right, okay, got it. And how's the research usage of a DHT client on mobile? So this has you.
How do you mean?
So for example, back in the day, I'm not sure if they're still around, Bertie. They used to run a DHT client on mobile devices, and what they were suffering is like this was just draining the battery because you had to keep the routing table up to
the
date
antenna
and so
problem.
on.
Yeah. I'm going to answer this in a roundabout way because hopefully it makes sense at the end. So if you're not online and I send you a message, you can't receive that message because it's peer-to-peer. But if we have blind peers, then those blind peers can receive the messages and forward it on to you encrypted, which is how we solve the availability problem. But mobiles will never be blind peers. So they're not every peer has to be the same. Mobile will probably always stay as client peers, and by doing that, you reduce a lot of the battery and energy cost and all of that. Yeah. But it's not, it's not foregone conclusion. There's still definitely some trade-off there. But I think I know, because I use Keys all the time, the capacity is sufficient that it works.
Yeah, I thought so that it's fine. I guess. What else do I have here? So, I mean, P2P networking is hard, so you're probably applying some hole punching techniques, I guess?
When we first started doing this, we called the company Hole Punch, because our secret sauce is the hole punching technique.
Right.
I can't speak to that so much because that's the bit that's where I came in once that was built.
Right.
But as far as I understand it, it's a statistically guaranteed method to opening the gates on the NAT routers, and from what we can see, it works very well, which you can see in the data because a lot of those million new users a month are actually coming from Russia. We have some conversations with people inside China, with having conversations outside of China. So it's effective. Right. And then,
cool.
But it's not 100% effective. For the 1% that it's not, then it goes through a blind peer actually, but as a relay.
Exactly. Yes, this is exactly what I wanted to know. So what the fallback mechanism looks like.
Yeah, it's just a message, so it works via a blind peer as well.
Yeah, sure. You mentioned UDP earlier. Does pair support like TCP transport or plus quick, or are these just raw UDP datagrams that you're sending around?
It's our own flavor. It's called UTP, I think, which is just UDP plus. So it's TCP-like, but it's not TCP because it's optimized for what we're doing.
Okay.
But Bear supports TCP. I don't know if it supports quick, but you could write a native add-on just easily, right?
Is this all written in JavaScript, or is it just a shim or like a layer?
JavaScript and C.
Sorry?
JavaScript and C.
JavaScript and C.
So
okay.
We find JavaScript's really good at rapid prototyping, rapid iteration. We have practices and have a pretty strict subset, but it's fantastic for getting there quickly. It's fantastic for onboarding people. It's such a commoditized language, and then with pairing that with C as well. So C is for the native add-ons in Bear, and then you have this thin, JavaScript layer on top.
To me, it just sounded like an unintuitive choice of using JavaScript for such a low-level system problem to solve. But you mentioned C as
Yes, there's C, but I think for something like this, JavaScript as an evented language is excellent for the mediator pattern, and in peer-to-peer, it's all mediator patterns. So I think it works really well, particularly for the mental model. But we are, as we move forward, more and more of the stack is being moved into C, right, because of efficiencies and cross compat and things like that.
Cool. Okay. Maybe one last question.
Sure.
So is there so you may have already touched on this, but in other P2P libraries, there's next to DHT, which is used for peer discovery, also some gossiping protocol. Is there anything like a module that supports any kind of gossip?
A little bit out my area, but I believe Kademlia is responsible for the gossiping. The Kademlia, it's a next generation BitTorrent algorithm that we use right down deep in the stack. You can
So
find that
yeah,
under HyperDHT.
Okay, so the DHT is just a key value lookup thing. So if you want to disseminate a certain message across within the entire network, there are like probably other protocols. I will look it up if there's anything.
We have something just on that, just as a side note. We have something really, really exciting come in that's not been released yet. It's still in the works, but search via DHT as well.
Interesting. Okay. Okay.
So that's a global search engine at that point.
Good. Okay. Anyone?
Any other questions before we get to the actual workshop portion? No?
Okay,
Cool.
I would have yet another one then.
Okay.
What did you want? Okay.
We can take one more and then one more if you
Right.
want.
Okay. The hyperdrive that you mentioned, is this in any way content addressed? Is content addressing is it playing a role in this whole stack that you mentioned?
When you say content addressing, you're talking about content hashing of
Yeah.
the content. Yeah. So pair links are a standard, and it's the pair protocol and then a key string, but it can also be the pair protocol fork.length key string, and then it can also be the pair protocol fork.length key string hash content hash or something like that.
Right. Okay.
So we have all of the forms, and if you want to use the full content hashed version, you can. But with the fork and the length, you're pointing to a very, very specific thing in a hypercore at that point. So I think there are probably, like if you're ultra paranoid, you can use the full content hash, but mostly we just use fork length.
Okay. Cool. Good. Thank you.
Yeah, sorry, I missed the beginning, but what I've heard is that you're making a distributed hash table kind of storage.
Sort of, but much more than that. It's a way to build applications at planet scale without servers.
But how does that differ from something like Swarm or?
Swarm? As in DHT Swarm?
Ethereum Swarm,
Right, yeah, not too keyed up on that. I don't know, can't compare them, but there's no tokens involved. Maybe that's the key point.
Thanks.
Stick around for the workshop and we'll get into it. Okay, cool. So if you'd like to follow along, take a look at github.com/holepunch2. Wait. Where's it gone? Pair workshop. Let me put this in bigger letters so it's easier to see. Everyone got that? Anyone need more time? Yep. Cool. Okay. So to do this workshop, you need to have Node installed. Because we use npm, we don't use Node with Pair. Actually, Bear is everything, but we use Node and npm because those are the things that people use. We don't use Node, sorry, we just use npm, but you need Node for npm because that's what people use to install dependencies. So if you don't have it, you can get it on Mac with nvm.sh or on Linux, and on Windows you can get it with nvs. You see it in the workshop. Oh, good. To install Pair, you just run. Oh shoot! Hold on, let me just sort myself out of it. But you run npx pair. Now, if I run that, it's going to do something different, I think. You know what? I'm going to remove Pair from my system just to show you how to do it. So what this is doing is it's executing an npm module that downloads pair from peers and installs it onto your system. The pair itself is actually a bare program. And the next version that we're going to release is also going to be using the same P2P OTA updates with bare approach that we published recently. Once you have it, you should be able to. You're going to need to export. You're going to need to modify your path. You can do it by running this command here. I don't need to because I've already done it. And then if I run pair, I should see some help output. Come on. There we go. That's a Mac thing. That's not a pair thing, by the way. When you put a new binary on Mac, it actually does a call back to Apple, I think. So this is the pair help. You can see some of the commands I talked about there: touch, seed, stage, build, provision. There's some other cool stuff. Info, dump is really cool because you can dump whatever you stage. So it's synchronizing from your hypercore back onto disk. Changelog is really cool, really fun. All right. Anyone need help getting pair installed? Because it's not as easy as it could be. Everyone good? All right. Don't forget to do this part. If you don't set up your path, you can't run it because it's pointing at a custom bin folder. In future, that's going to change. So once you're set up, you can go to the first exercise. And what we're going to be doing is we're going to take the boilerplate. How much longer do I have, by the way? Like 45 minutes or so? 50 minutes?
Well, officially the workshops end at 3:45.
Great, perfect. Lovely, thanks. Okay, so we've got this boilerplate, hello Paraelectron, and we're just going to git clone that into a chat app. So I'm going to go git clone. Oh, did it twice. Git clone hello Paraelectron into a chat folder. Let me make that a bit bigger. And then we're going to do run this command. And what that does is just sets the package.json name, the package.json product name, and the package.json version. The product name is what's used when we actually do a build. So typically it has an uppercase letter in it. And the package name has to be lowercase. That's why we do that. And then I'm going to npm install. While that's happening, let me talk you through the boilerplate. So the boilerplate is, the README of this boilerplate has the full explanation of how to do this end to end. Talks about the architecture, talks about how the updater works, talks about where the storage lives, how you can set your own storage flag, which is important when you're developing peer-to-peer applications, because it's all about where something's stored. So if you run two applications locally with different storage targets, then you're simulating a peer-to-peer interaction locally. They actually go and connect outside and then hole punch back into yourself. That's why that's important. The workers, which is the back-end stuff, it talks through the deployment stuff I've already been talking to you about. You can see some of these diagrams are quite similar. So this is something you can work through like end to end to get to a full production deployment of a pair app. Now that's installed, I'm going to do npm start. Oh, my bad. I missed a step. So the package.json has an upgrade field, and it says your key here. So we need to give it a key that we're going to stage to later to do peer-to-peer updates. So I'm going to run pair touch. And that's given me a key, which I'm now going to take and I'm going to set on the upgrade field, like this. And now npm start should work. Great. So that's launched an Electron app, and it just says what the version of the app is. I hope someone hasn't died. That would be terrible if they have, after saying that. So that's that, exercise 2. Now we're going to make the actual chat app. So what we have here is a little diagram of the flow between the pieces of the Electron app and a remote peer. So the Electron app, it has renderer app.js. It has preload.js, which is actually part of renderer, but it goes through this context bridge thing. It's Electron stuff, don't worry about it. And then there's Electron main.js, which talks to the renderer. And then there's workers main.js, which is bare runtime. That's what's running the actual peer-to-peer code, right? And that's all talking over IPC, RPC. Then from that, it's doing a write to the peers via Hyperswarm. Every time Hyperswarm detects that a new peer has joined, you get a peer object, and then you can listen for data on it, and you can write to that object, and that writes to the peer. So, we're getting the data flow is going from the front end UI, the web view, over to Electron main, over to the bear worker, over to the remote peer, back from the remote peer, and all the way back into the renderer. So to do this, we're just going to install some dependencies. We need Hyperswarm for the DHT, Hypercore Crypto, and B4A, which is just a buffer manipulation dependency. So I'm installing those now, and then copy paste. So we're going to take workers main, and we're going to put this code in it. You can see here that we have a Hyperswarm. We set it up. Const swarm equals new Hyperswarm. When the swarm gets a connection, it gives us a peer object. And then we're listening for data on that peer. And then we're calling our send function that we've made with this object. The send function is here, and all it does is it writes to this pipe, which is a frame stream over a socket, essentially. Bear.ipc is the socket. When you start bear as a worker, bear.ipc is the socket to the parent. And then when data's coming in, we take the message, and then depending on the message type, we either join a swarm with random bytes, or we join a swarm with provided bytes. So that means that's the same exact flow from there for creating a chat room or joining a chat room. And then if it's a type message, then we loop through every peer that we're connected to, and we just write the message text to them. And that's it. That's pretty much that's the whole thing in terms of all of the peer-to-peer logic for a ephemeral chat app. There's no persistence here, but that's everything. So I'm going to put that into workers main.js, like so. Oh, wait a second. Someone's updated this. I'm going to keep the what we also have in workers main right now, and it's a good thing, but this needs updating in the workshop. is the updater is running in the worker. The updater used to be running in Electron main, so I'm going to copy paste that code, but it's going to go between these lines here. Hopefully this works. I'm not sure if it's going to work because it's a bit. I have to debug it if it doesn't. That's fine. And then got some HTML here, renderer index.html, which we're going to just replace verbatim. You'll see it. All it is some chat stuff for joining and creating rooms. And then renderer.app.js will give us the glue code for receiving data from the worker and vice versa, and making that work with the UI. So that is renderer.app.js. Sure, there's not an update. Okay, I'm not going to prove updates with the chat app. That's just not going to happen. Right, now that's done. npm start. And then we've got a chat app. And then if I create another process, npm start with a storage flag. Oh, that's the wrong Now I have two instances of the chat app with two separate storages. So you could also, if anyone's got it running on you can also join, but let me know if you have it there. So if I create a room here. Yeah, so when you press create, it joins the room with the random bytes. So we're creating a topic on the DHT join room. That should be happening faster, but I've just realized I'm on my, I need to get on let me try it on DappCon guest. And then the idea is that you then join that topic on the other one. I don't know why that's being weird right now. Let me try creating one on this one instead. Cool, just checking. Yeah, so the boilerplate's been updated, and there's a little mismatch here. I'm going to have to debug this real quick.
Works on my machine.
Does it?
Yes.
Fantastic.
But I didn't, so I used the code from the README developer. So I didn't do
Yeah, you didn't do the little thing that I did. Let me just do that and see if that works. Okay, cool. So I've got this topic, and then I join that topic, and now I have are you on Keat at all?
No.
So I'd share the link with you on Keat. That's the thing, you have to share the topic out of band some way or another. But if I gave you this topic, it would work. A lot of the time we do this as a remote workshop, so it's really easy then because you're like in a Zoom call or something, you know. But trust me, it works. Any questions about that? About that build?
Maybe this IPC thing, what is it exactly?
What, the bear.ipc part?
IPC,
Yeah.
how the socket thing works. So, I have suspicion, but maybe. Okay, thank you. Yeah, good. How does the IPC thing work? As I said, I have a suspicion how it works, but maybe you can explain it again.
Sure. So Electron main.js, right? We have pair runtime run. And that, what it's actually doing is it's running bare sidecar. Bare sidecar is just a duplex stream that spawns a bare that's packaged in as a dependency, but it's just a native. It's still just a native binary per OS that you just install it in, and then the IPC is the stdio3. So you've got 0 for input, and then 1 for out, and 2 for error. We do FD3, and that's just the pipe then.
Okay.
Yeah.
Cool.
Nice. Anyone
I
else?
was just wondering if it's, I don't know, if this is a Unix domain socket or how you connect all of these pieces together. But okay, this is different from what I expected, but it's cool.
This is after like 4 years of iterations, and it's where we sort of landed for, it's not just about like the technology side of it. It's about what makes sense with lots of people working on something at the same time. And helping people framing things in a way where it just makes sense to like onboarding people quickly, because that's what we've been doing a lot. Let me also show you. Sorry, I'm just going to go off piste here and just go do whatever. So I want to. I'm going to clone the boilerplate again, and just straight into hello pair electron. Because then I can show you the update flow because of that little wrinkle there. So npm install. And we're going to do pair touch again, create a link. I'm also going to set the version to 0 just to confirm it. And then npm start. Great. So now what I'm going to do is I'm going to do npm run make a build. So what I'm doing is I'm going to go through the productionizing flow, and then do a peer-to-peer update, and you'll see the version hopefully change if I don't mess it up. So I've got some artifacts here. Great, that works. So now once you have a build of an app, you can use the pair build command to piece it together. It's a really simple command. All it's doing is copying, but it's about structure, right? The point is that you want to be able to build on Mac, on Windows, on Linux, and then put them all into one folder. At some point, we'll extend the functionality of pair CLI to make that easier, because we could totally leverage our peer-to-peer stuff for making like a build farm or something. But at the moment, it's like manual on purpose because there's less that can go wrong. I'm building on a Mac M1, so this is a Darwin ARM64 app. So I'm going to do pair build Darwin ARM64 app out hello pair blah 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 hello pair app. And I'm going to set a target folder also for out build, let's call it. And I also need to provide a path to the package JSON. And that's really important, because what a build folder is the multiple architectures and then a package JSON at the top that has that upgrade field on it. And that's what it all comes down to, is that package.json at the top with the upgrade field on it. So if I run this, now in the out folder, I should have build. Yeah, so this is it. You've got the package.json at the top, and then you've got the ByArc folder, just with Darwin ARM64 in it right now. But you want to have, like, for a full production app, you're going to have everything. So with that, what I can do is I can cd into the build folder, or actually I'll do it from the outside. Hold on. So out build is the deployment folder right now. So I'm going to pair stage to the upgrade link, which is this. And the pair stage command looks like this. Pair stage flags link dir. So I'm going to say pair stage with the link, and then point it to, well, sorry, I'm going to do a dry run first. Always dry run first. And then that's out build. That's my deployment folder, right? So once I've run that, you can see that it's printed out this diff. Pretty big because it's an Electron app and it's the first stage. But the point of the diff is to verify that every change that's happening is intended. And that's why I dry ran it, because it's not actually written. It's just shown me what changes it would make. So now I'm going to run it again without the dry run. Cool. And now I should be able to seed this link. And that's now exposing that link to the DHT. So if there's something else really cool that I just want to show you that's on the side of this. We don't have this out yet, but that will fail. There's a pair install command coming, but you can preview the command with npx pair -install and then a link. So if I run that, it will install the build that I just made from myself. You can see there's a join on the seed there. That's this. That's going to install it into my applications folder. So it will install UI applications, and it will install command line applications. So there's a side advantage here that the same update drive that you're using everything actually can be a peer-to-peer install source as well. So if I open applications hello pair now, oh, don't be like this. That's not the one. Let me try again. Great. OK, maybe that was the one. Now, when I opened it, there was a join that popped up on the seed. If I was to give you this app and you opened it, you would also join in it, right? So now I know that this peer, this app that's now a peer, is ready to receive updates. So what I'm going to do is I'm going to make a change. And all I'm going to do, because it prints the version, I'm just going to bump the version, right? So I'm going to do npm version patch. Oh, the git directory thing. I'll just do it this way. Yeah, I'll just do it manually. So I'm going to bump the version, and then we go through the build flow again. So it's npm run make. And then once we've made it, we build it again for the multi-arc folder, and then we stage it again. And then once we've staged it, the update should go out. So pair build again. Everything's exactly the same this time. And now pair stage, going to dry run it first. And we can see this time the diff is much smaller, right? Because we've only made a small change. The things that have been updated are updated by the Electron make flow, some plist stuff, some that Windows stuff, the package.json itself inside the app, and then the top level package.json. They're the same package.json. So that all makes sense to me. So now I'm going to run it without the dry run. But before I do, let me make sure to have this app visible and the seed visible. So I'm going to hit return in this one. So that's staged. Yes. Good. So the that should come through, but it's not yet. This is always the bit where I'm like, oh god, it's not going to work, is it? But I might have to restart it to get it to work. I'm not sure why that is, but it generally happens when I'm on the same machine. But if I'm using two machines, it doesn't happen, you know. So you see that the length increased here from 1263 to 1273. That's the thing. That's the version. That's the peer-to-peer version, right? If I do pair info of the link, then it should tell us, okay, it's 1273, so we know that it's been updated, but the app has not received the event. Of course it's not. So have we got any errors? Like I say, this was updated recently, so it might have been broken. I don't see errors. Let me try shutting it and starting it again. Sorry, I'm just trying to think about why this might be. My bad. You could just trust me that it works. It's how we do updates in Key all the time. We know it works, but I think we have a lot of guys that are contributing all of the time and improving things, and it's possible that there's a bug that's come in here between the last time I checked and now. That's the peer join. Oh, okay. That's weird. I restarted the seed, and then it started working. So I'm going to take that back to the team and figure out what the hell's going on there. But you can see that it's actually picked up the update this time, and it says updating. And you can also see that there's an upload from the seed happening, because it's uploading to this peer over here. And it says the update is ready. Still downloading there, that's weird. Or uploading. And then if I press apply update, it restarts with a new version. That intermediate bit, I need to research exactly what went on there. But like I say, when it's on the same machine, it's sometimes a little dicier than on different machines, but I'm not sure if that's something to do with it. And with that, you have peer-to-peer over-the-air updates.
So this update now went through the internet though? Because other
yes, it went out and back in. Yeah. Any other questions? We've got a cool snake, like on the workshop, you can keep going through, and then we've got like this cool game that we've made called Snake. I don't know if you've heard of Snake before, but this works on exactly the same concept as the chat app, but instead of it being chat messages, it's structured data that determines the position of a snake. But it's the same architecture, it's the same exact thing all the way up and down. Here you've got like the frame stream, you've got the updater, you've got join game instead of join chat, right? But it's all the same thing. You're just joining a swarm with a topic. The two peers connect, and then they can play Snake with each other as well. There's a whole part 2 that you can take a look at here, probably in your own time. But if you work through part 2 of this workshop, you can go through the same deploy flow that I just showed you, but you can take it further and go to provision and multisig as well. I could show. We got a few minutes. I could show the provision stuff. So let's say that we're at a point with this link that we're like, okay, good. Version 0.01, that's the production version, right? So the next step then is to go, okay, well, it's time to create a provision drive. So I run pair provision, dry run, and it takes a versioned source link, a target link, and a versioned production link. When you're creating your first pre-release key, or your first provision key, there is no production link yet. So you just use a 0 versioned link, but what it does is it synchronizes everything from the version production link onto the target link, and then on top of that, it overlays everything from the version source link onto the target link. And that way you have a replica of production first, so it's always correct, and then you have your changes on top. So I need to create a new link for this, so I'm going to do pair touch. And I actually need to create a new version now because, and this is sort of a problem for CI or whatever when it comes down to like a proper deployment. But I now need to update the upgrade link. I think actually we've got a thing where you can do, I'm not going to do it here, but you can do like develop like stage and then production and then have a link per. But the raw way is to update the link. So I'm going to update that, but then I need to also stage that because we're going to be syncing from the stage link as a source. So I'm going to go pair, stage, dry run. Oh wait, sorry, I need to do a make first. So npm run make, and then I need to build, and then I need to stage dry run, and then it's got the provision link that we've not provisioned to yet. So now build, and now stage dry run. Yep, that looks correct. And then without the dry run, and now I can do the provision. So my stage drive is aligned with the future provision drive. So now I go pair provision. The source link is the versioned stage link. So you can actually find the version stage link in the stage output kind of discreetly here. And now the target is what we've just set the upgrade field to. And that doesn't need to be versioned. And then finally, there's a production link, which we don't have yet. So I'm going to pass in the source link at 0, 0, so it syncs nothing to start off with. And, oh, don't forget to dry run first. I think because this is the first one, there should be a diff, but because it's the first one, there's not. So this is saying, yeah, good to go. Now I provision. So this is getting more serious, and it says, like, are you sure you want to do this? I'm waiting 10 seconds for you to bail. And then when it's done, it should then have synced, and we can seed that. And what I'm going to do, just to make sure that it's worked, is I'm going to remove hello pair from my system. Oh, because it's running. And now I'm going to try to do that install again with the provision key instead of the stage key. See the join, see the upload. We didn't need to bump the version for that build. Generally, you always bump the version, but because we're swapping the upgrade key out, you don't need to bump the version because you're starting with a new key, a new link. Now it's been installed to the applications folder. Open it, great, cool. So this is now a pre-release link. The step after this would be pair multisig. And this is where it gets a little bit heavier. We're not going to do this. We don't have time. But the flow is this. You create signing keys. So each signer needs to generate their own key. So it would say, like, myself, yourself, maybe you, right? And then yourself, and then yourself, and that's 5 of us, right? And then we're going to say, okay, each person is going to generate a key with a password, and that's then that writes that out. It's sort of like SSH, right? To this .pair folder in your home. So that's your public key for signing. And then what you do is you create a pair.json file in the project root. Oh, it's already there with those public keys. So I've just lost that. Pair multisig keys get. Cool. Yeah, it creates it. If you don't have it, otherwise get will just give you your keys. So that would be the first key, and then maybe I take 2 more keys and we just do a 2 out of 3 quorum, whatever. Once you have that, you then run pair multisig link. Oh, I need to hold on. Let me just fudge this. I'm going to do a 1 out of 2 quorum, and hopefully it lets me use the same key. Uh-huh. See if pair multisig works. Multisig link works this time. Ah, God damn it. Cool. So once you've set up your pair.json with your quorum, you use pair multisig link because instead of pair touch because it's determined by your multisig configuration. If you change the signers, you need a new link. If you change the quorum, you need a new link because it's basically a contract at that point, and the link represents the contract. And then that would be then set, that pair multisig link would then go on the upgrade field, right? And then you'd go through that whole process again, where you'd like stage the new multisig link and you'd provision the new multisig link, because this is now about production. And then you'd go through the multisig flow, write it to that link, and then at that point you've actually reached the production piece where you can actually give this to your users. You would version, you'd make the distributables, you'd build a deployment directory, you'd stage. You've seen me do that a few times already, right? And then you provision. And then you go and write pair multisig request, right? So I wonder if this will give me a little preview if I do it like this. Pair multisig request. I'm going to version it as 0, 0 and see what happens. No, it's going to freeze. No, it needs to be seeded. But yeah, so I've not written to it yet, so I can't do this part. But with what pair multisig request does is it creates a signing request that you then give out to your signers, and then each signer runs pair multisig sign and pastes that signing request in, and it signs it with their keys, and they give their responses back to whoever's actually running the release, right? So say it's me, I get my response from you, I get my response from you, we put them together, and then I run pair multisig verify with the source link, the multisig link, the signing request that I sent out, and then all of the responses. That's basically a dry run, but we've made it a separate command because it's that important a step that it should have its own command. Once you know that that's all good, then you can run pair multisig commit with the source link signing requests and responses. And at that point, it actually writes to the link, and then any users that are using your app will receive an update and get the update and go through that flow that we've already seen with stage. But that takes us to the conclusion. That takes us to the full end-to-end flow of creating production and deploying and installing production peer-to-peer apps. So questions before we wrap, or how are we feeling? It doesn't have to be a question. It can be a take, if you like.
Pretty cool.
Ah, that's very nice of you. Anyone else got any compliments for me? All right, cool. Does anyone, if anyone wants to connect on Keat, we can just do it. We can wrap now, we can finish this, and then as soon as I figure out where I've put my phone, we can connect on Keat. Here it is. I'll wrap it. Thanks very much, everyone. Appreciate it.
to cool. Hi everyone, my name is Josh Davila. I'm the co-founder of Bread Cooperative. We're a worker self-directed nonprofit where we build, in large part, solidarity finance applications using crypto as a way to build them out and expand the existing solidarity economy. And we're also a developer studio, so if you're looking for people to help build your products. But today's talk is called Save Money Like Your Ancestors, Stacks and Other Solidarity Tools. So I'm using just, what I'm going to do is going to go through a presentation that talks a bit high level of what we've built, and then I'll show you a showcase of what it is that we're shooting for, that we're trying to build out. So yeah, Bread Cooperative, we are, like I said, a worker cooperative. We've built quite a few different applications. One is the Solidarity Fund, in which we combined a local currency with a credit union built on Gnosis Chain, where users are able to give XDAI. In return, they get bread tokens. And what happens in the background is yield gets accumulated and distributed to a set of member projects based on a vote from bread holders. So this product has been around for a couple of years now, and it's been working quite well. And now we're wanting to expand our portfolio and build some more solidarity tools in our tool set so that we can expand the bread ecosystem. And that's why we're talking about stacks specifically. And here are the tools. And then down the line in the future, we have another product in mind called Safety Net, which is a kind of mutual insurance based on the bread funds scheme in the Netherlands. But so Stacks this implementation is based on a ROSCA, or a Rotating Savings and Credit Association, which is actually quite common in the Global South and in other places where you don't have easy access to financial institutions and banks. In Mexico, they call them tandas. In West Africa, susus. You may have heard many different names for what is effectively at least very similar type of financial arrangement. And so what we've done is we've created a smart contract version of what is the most basic version of a ROSCA. Each country or culture that does something like this, they'll have a slight variation. It'll be slightly different. So the one that we've made right now is just the most basic version, and in the product that we have so far is basically the proof of concept for being able to use smart contracts to develop this. So how does the savings circle work? Effectively, it's a way to collectivize people's savings while offering zero interest loans. Relying historically, for the most part, on social trust. So let's say we have 3 people in a group who all want to do a savings circle together. We would all of us would deposit the same amount of money in the first round, and one person would receive the full pot. And then in the next round, we would all put in the same amount of money in the pot, and then the next person would get the full pot, and everyone would get their turn in order to receive the full pot of money. And so in the end, once everyone has had their turn, essentially everyone's debts are neutral, are at zero, and everyone's paid off. It's effectively, depending on the position you are in the group, you are either a lender or a lendee, and oftentimes the direction may change, or the ordering may change, that people have a variation of where they sit along that spectrum. And so this is a very basic form of a ROSCA. In places like India, where they do chit funds, it works slightly differently. They'll have a kind of auction system where people can bid on whether or not they take the pot. So those who are willing to sacrifice more early are able to get earlier access to liquidity. But so this system is, why do something like this? I think for some people, if you've lived maybe in places where you have more stable financial system, it may seem kind of strange to do something like this. Why would you intermingle these things that seem your friends with money? But actually, there's a lot of reasons why you would want to do this. One, it allows you to build relationships with others in your group and in your community. There are very small loan amounts as well. You have short repayment periods. The transaction costs are low, and you're putting mainly social collateral on the line, not any other type of financial collateral. So this is particularly useful for people who don't own very many assets, of course. And there's a clear framework of incentives, and it naturally reinforces social ties. A really interesting study in Vietnam found that farmers that participated in Raskas were actually significantly better at savings and were able to reach their savings goals compared to those who were trying to save solely individually. So the kind of psychological effects of the social, just kind of like doing it in a social way tends to have better outcomes for reaching financial goals. And so some of the kind of major use cases for saving circles would include major life expenses. So if you're needing to buy books for your children, it's a good moment to receive this injection of liquidity, which maybe if you were trying to save individually, it might be more difficult to save for that. But because you have this social pressure to save money with everyone else, and you know that you're going to receive this injection of capital at the time when you need it, you'll be able to make these bigger life purchases. So you can buy books for your kids, you can pay for medical expenses as they come up, you can buy a car, maybe you have someone in your family who's getting married, so for your wedding. And as well for business expenses, it's really nice to have, you can have effectively a zero interest loan for starting your business. And so if you're planning to make money off the thing that you're putting the money into, then it's a really good deal, because otherwise going to a bank, you are going to have to pay an interest rate, and depending on where you are, what your credit history is like, it may be a pretty extractive percentage interest that you'll have to pay because of, like for that loan. And so why a blockchain? So some of you maybe have noticed that with social reputation or collateral on the line, it does mean that there is a space where people can steal money from you, right? Usually saving circles are done in cash, and one person or two maybe be the ones who are tracking everything for everyone in order to, so that everyone doesn't have to do the math behind a saving circle. And so I know that in Mexico, sometimes the tanda, what they call, is sometimes associated with Ponzi schemes, because the person who is managing the tanda will run away with the money. And so this is something that we think blockchains are actually pretty good at trying to prevent, or at least able to track where that money is going and where it is. And rather than kind of relying on purely just trust in somebody else, you're able to rely on the cryptographic guarantees that blockchain enables by offering some kind of decentralized escrow service, right? Where you can put money in the smart contract, so you're not trusting a person, but a deterministic computer code to be able to pass around the money and the liquidity as agreed upon. It also allows you to do a level of collective governance digitally. It allows you to, you have pretty cheap transaction costs, especially on Gnosis chain, where we're building this largely on. It also, I think what's really nice is that although usually saving circles are very informal, with a blockchain we're able to automatically record any movement of funds, and therefore we can also record a kind of credit history for people, because they are engaging in loans, right? People, when they do it, they may not necessarily see themselves as giving out a loan or like taking out a loan, but they are engaging in something like that. And so we think this is something down the line where you can bring a lot of people who are not involved in, or are not like able to enter into the traditional financial system, to be able to build that credit history so that they can qualify for other things down the line that may be useful for them through that require a credit score. Another thing that's really interesting, I think that that isn't exactly possible without a blockchain, are programmable incentives. So due to people's actions, we can reward them for reaching their savings goals and things like that. Of course, with crypto, you get resistance from debanking. So we know I've spoken to a group in the US that facilitates saving circles and tandas in California for a lot of undocumented people, and they run the risk with a lot of them that they get their bank accounts blocked because they don't have the right documentation, or they're not able to access banking services. And of course, there's DeFi, and then there's as well, at some point in the future, we'll have a nice portable identity solution, hopefully. So we have a real demo that is public. If you go to our website at bread.coop, you can find a link. There's under one of the menu submenus, there's stacks, and you can find it there. If you aren't already in it, I would highly recommend joining our Bread Co-op Friends Telegram group, which is just here in the corner. We'll share some updates there about the product, and then also we'll have a park hangout on Friday if you want to come by. The demo of the actual application right now, we think will be good to do a bit later. So Francisco, who's sitting right there, find him if you want to try out the actual demo of the product. What I want to show you, I think is more interesting just for this context, is what we're trying to build towards. So I've made just kind of like a vibe-coded demo of the type of features that we want to build towards as a way to illustrate and create a story for what we want to get towards, and see if there are any interesting collaborations and what you guys are thinking about doing and building, so we can maybe team up and see where we align. So yeah, thank you. I'll maybe stop here before I get into it. I don't know if there are any maybe questions just to check in. I explained it really well then. Okay. So this is the kind of showcase of the product. So this is kind of aspirational of where the direction that we want to go with this product. The idea is that you would come to the Stacks website or Stacks application. I mean, it could be that Stacks is actually integrated into other types of applications, but just for this showcase, you would create an account in a way that is more like a Web 2 type of experience. So we want to abstract away the crypto aspects of all of this, and by creating an account through this, like through the Web 2 way, we can just offer you a wallet that's already inside of the application. But you would maybe share a little bit about yourself. So what are you trying to save for? What are you trying to do with this application? And that will help us be able to recommend different types of services or different types of things for you to go for in the application. Continue. Maybe we'll have some type of identity to some degree, privacy preserving in some way, which will be important to explain later down the line. But because this is like peer-to-peer lending, it's something important to have some amount of identity so that we can track who someone is and whether or not they're a trustworthy person. And other people can also verify that this person is who they say they are, and they can trust that this is the right profile for me to start a saving circle with that person. And so I think you'd first start off on the dashboard. So in this case, we're Diego. And Diego has a few different stacks that he's created. And so if we click on Create Stack, the idea is that this wouldn't be just for Roscas, but that in fact there are many different types of collective savings types of financial arrangements that we could implement in the application using smart contracts to kind of facilitate them if they make sense. So you could choose with a Rosca, the classic setup. Maybe you want a chit fund because you're based in India and that's what you're most used to. Or we can do things like competing with your friends just to save a bit of money. We can look into the literature of what other countries, however they do their type of collective savings. There's also things called ASCAs, or Accumulating Savings Credit Association, which is where everyone puts in money and people are allowed to take out a loan based on a certain multiple of how much that they've put in. So that's another version of a kind of Rosca, but accumulating. And so you would continue and you would put in the information about the circle that you want to join, whatever else, and then you would continue, and it would, well, we skipped it, but it'll ask you to invite your friends, and then you can make it and start it up. And so if we go to the specific Rosca, where maybe I have a Rosca with my family, where we're all sharing some money together, I can see here, where I am in the line and who is next in the order. So I know that I received my payout first, so I've already been paid out, so that means that I'm effectively taking out a loan from everybody else, but I will pay it off over time in 3 more installments to these next 3 people in order to pay it out. And so down here, I think we're doing $500 per week or per month. And so the pot that I received in the beginning is $2,000. And then we would hope we would have, of course, to try to make this as easy as possible, a kind of automatic depositing system in the back end. So yeah, so each of these different types of stacks will have a different kind of user interface based on what it is exactly you're doing. So a chit fund will, you can place a bid in order to make a bid on the pot. If I go back, and so forth. And so this is just like kind of like the high level overview. I can go here and I can look at different types of stacks. I can see the ones that are active right now. Maybe they're pending because someone has set it up and I just need to verify something, or someone else needs to. The ones that are completed, decommissioned. And because collective savings is not just a financial arrangement, it's also a social arrangement. What we think is going to be really important is to have communities, or to have spaces where people have a boundary for who they're interacting with and who they're wanting to find others to engage in saving circles or stacks with. And so we're imagining that this could be set up in many different ways. It could be communities that are based on people wanting to save towards the same goal. So let's say if I really want to buy a home, and I really want to look into a collective savings arrangement as a way to be able to afford my first home, because technically I could afford a mortgage, I just can't afford the down payment, maybe, is the issue. And so I want to find other people who we can each take turns by offering a little bit of each other's liquidity so that they're able to better afford the down payment that is required in order to purchase a home. So in our community, we can scroll down and we can see activity that's in it. We can see the stacks that were started from this community. We can go into the discussion. We can see the forum. We can see what people are talking about. Maybe people are offering tips and tricks for how best to save money for a home, and what are the regulations that are at play for if you want to go begin purchasing a home. You can see the other members, where they are. So maybe you can also find other people within this group that are also, maybe you want someone who is also in a similar context, so also in the same country, and also trying to save for their house. And earlier when you saw on the sign up, we were asking how much are you wanting to save? What is the goal that you want? So we can kind of offer a service to matchmake each other. So I think it's, it's almost like dating a little bit, but you kind of need a little bit of a push to come and meet each other and get to know each other. And we're imagining potentially, some of these communities could have some form of governance in them as well. But additionally, what I think is kind of the most at least on our side, what can be interesting as far as a strategy for sustainability of the product is to offer this as a kind of employee benefit to those who are already engaging in saving circles anyway. So in Mexico, we know that tandas are very commonly done with coworkers. And so rather than just kind of like keeping it purely informal amongst coworkers, an employer is actually incentivized to get employees to achieve their savings goals. Like an employee that is able to achieve their savings goals and achieve the lifestyle that they want within the boundaries of what they're paid is generally a happier employee. And so what we're imagining this is a place where employees would be able to offer matching funds or a kind of incentives for coworkers to effectively get along and try to collectively save money with each other, and if they are successful in saving money together, that they would get a little bit of extra on top of that. So a little bit of incentive to do that. And so inside you can kind of see, maybe internal discussions about the company or whatever else that might be interesting. We'll have to see when we approach employers what they want. And yeah, so that's kind of those are communities. Inside, though, we want a really Web 2 type of experience with the wallet, so you can see, I have this much amount of money and maybe this much amount of cash available. My portfolio is 3,000, but my cash is 2,500, so I have maybe $500 right now that's being deployed in one of these stacks. If I go to trust score maybe, so here, like I said, you're effectively engaging in peer-to-peer lending. So you're building up a credit history effectively. Like if we are tracking, that you are making these payments or not making these payments, that's effectively the same as making a credit score. And so we think this is really important as a way to build trust within a digital space, that you can see that someone has been able to effectively save money and pay their obligations over time in a way that is effective and builds trust. And so we can kind of create different trust tiers, where if you've completed so many Ruskas with people, then you're a certain tier, from newcomer to a contributor, that you're reliable, that you're trusted, or maybe you are a pillar of your community because you're always on time with all of your payments. And so this is something that we think as well, especially in the case, this is something we've discussed a bit with in the United States with people who are undocumented, that a way to potentially take this credit history and turn it into something that you can build as a real credit report. So in the United States and also in many other countries, you're able to submit data to credit reporting agencies. So that way you can build a credit score in the official credit agencies. So this is something that would take, a bit of research into knowing which countries have this as a possibility and what their data standards are. But it's something that we at least have the basics to be able to fill in that information. Additionally, we think it would be interesting to have matching funds. So to have a way for anybody to be able to provide matching funds so that specific types of people maybe who are reaching their savings goals maybe would be incentivized to achieve them and make a little bit more money. So I'm imagining philanthropists maybe who want specifically to incentivize women in Mexico. So if we could do something like a ZK passport as a type of identity solution where you can say, you can prove that you have a Mexican citizenship and you are a woman, and we just need the ZK proof for that. We don't have to store that information anywhere. Then that way we can validate and we can go to philanthropists and whoever else that they can go and they can effectively, very easily be able to do this type of impact work that they would want to do, and we can prove that impact with on-chain data. And so, yeah, it could be, people who really want to, we can have like an endowment for those who are saving towards homes or are saving towards certain goals. Crypto makes it very easy for these types of programmized incentives. And then maybe the last thing I'll show is the marketplace. So like I said, what we're trying to build is effectively the super app for collective savings, right? So whatever kind of financial arrangements that involves collective savings could be an interesting addition to this. And so when you have a lot of people who are saving money, you're also creating a type of power. So the way that often producer cooperatives work is that they pool their money together in order to buy things in bulk. Right, and it's kind of like if you've been to the U.S. and go to Sam's Club or whatever, you go to the grocery store where the bigger thing that you sell, the cheaper it is per item. The idea is that here, with these groups who have money that they're saving together and they're wanting to spend, that they would be able to spend that on things in order to receive discounts on products. Of course, the easiest ones to offer would be digital ones, so maybe you get a Gnosis VPN, hint on with the discount if you buy 10 of them at once. And of course, the science shows psychologically that when you make group purchases, generally people have a stronger attachment to them because they're doing it in like a social setting. So we think there's like a business aspect to all this as well. So we could approach different types of vendors. So yeah, maybe I'll end it there, I think. So have time for maybe some questions, but this is kind of aspirationally what we're trying to go for. We have our proof of concept version is publicly available. Francisco is the one you want to go to, and he'll set you up, and you can try it out. And we'd love feedback on it. It's much more basic than what I showed you here, because we're trying to get the base primitives correct before we like really start to expand out. But yeah, and then if you guys come to our park hangout, then maybe we can also try some saving circles there. But yeah, would love to. I'll end it here and maybe check if there are any questions. Sorry. Oh, we also have a booth downstairs as well, if you want to talk.
So thank you for the presentation. I understand this is aspirational, but where do you want to start? Like, do you want to pick one of the savings options and then start there, or do you have a multiple in mind? Like,
yeah. So right now we're starting with Roskas, because that's what we started with. And then I think the idea is that we're going to start with the communities that we're closest to. So I think part of the still the problem that we have to solve is onboarding. Onboarding is a big issue. So right now, kind of people who have crypto are the easiest ones to approach because they already have stuff on chain. Of course, we right now, you know, there are options, of course, for people to onboard, but to kind of go to people who have never used crypto before and ask them to onboard is kind of like it's a whole thing in itself. But we think that there is a lot of promise in some stuff that are coming out. So we're trying to talk to other service providers like Minerium or, I mean, potentially Gnosis Pay or whatever else, where they can offer maybe something like an IBAN for users to be able to more easily onboard. So they can just make a bank transfer and then they can have the money in their accounts. And I think that would feel kind of one way. But I think as well we're hoping to do a pilot in Nigeria. So we have like a group there. We're working with a philanthropic group that offers solar-powered equipment to rural communities in Africa. And the idea is that they would use the money that they save from the solar-powered equipment in order to start a savings circle, is the idea. But I think and then we're also speaking to Logos as well as a potential partner in all this. But it'll depend on, I think they each have kind of slightly different use cases. So the Roskas, I think, are going to be people who have, experience with Roskas. But in the case with Logos, I think the thing that we're going to have to build is rather than the one person receiving the full pot, it's something where people are just collectively savings, and it goes to like a shared wallet or something like that, where they can govern how they want to use it. So.
I was going to ask a follow-up question, but you already answered it, like which market you were going to choose to run a pilot with, but I guess Nigeria is one of them. Yeah. Have you thought about using MiniPay and like doing a mini app inside MiniPay to like get distribution for that market?
Not yet, but I'm happy to to explore it. Has anyone done a Roska before in here? Yeah. For the recording.
Oh, thank you. Yeah, so I think it's very common across Latin America to do this kind of thing where people mostly, well, I know in Guatemala it's mostly women who get together and put in money every month, and then one person gets some cash every month. And it's also like a community event, like they get together and cook food and eat and like gossip, and in the end the money is given out and people use it to pay, different things, but same concept, I guess. Yeah.
Right.
Yeah. So my question is about trust, because those practices that are pretty common in Latin America. For example, how I have encountered them is that my ex-girlfriend, she had a friend who was suddenly started to be very pushy in terms of like, hey, participate to this thing, otherwise you wouldn't get their money back because, they're Ponzi schemes in some forms, right? So, so at least that was how it was imported in Italy, I guess. So they were also sold as a space of mutual support between women, but in reality, it was like a big scam. So here, how do you prevent the people stop paying?
Yes, I mean, I think there are like, of course, like the way it's set up, like it relies on trust, like kind of normally. So you have to be careful with who. Usually, you pick people to do it with that you have some sort of relationship in some way, and that they have some sort of social reputation on the line that they wouldn't want to lose, like to their community. I mean, I'm also curious, like in Guatemala, how if this is, I assume this like is a problem every once in a while, or I don't know.
Honestly, no, I never heard of this happening. I guess the ones I knew about was smaller, like only people who really know each other and have been friends for a really long time, or coworkers, but that have worked together for. It's not like big groups, like maybe 8 people, 10 people. So if it happens, I mean, it would be like a big. Everybody would know you stolen from your friends. So I guess that's like the big deterrent. It's like everybody knows who you are, and then if you don't put in the money, not only you'll never get invited and all of this stuff, but everybody's gonna know you're a thief. So I guess it's very like community, it's very tied to the community base. I don't know how scalable that trust is, but that's, I guess, the big problem.
Yeah. So like, so I mean, one of the things that I know that like in Egypt, there's a really big digital platform where they do also similar kind of thing as saving circles, but they have like legal contracts that you sign as part of like the sign up. So you will get in a lot of trouble, I think, I think they'll go after you if you don't pay in, and so it's like a very large saving circle effectively. But what we're hoping is that here we can use DeFi to earn a bit of interest out there in order to fund insurance, and potentially offer that as like a separate product or something like that, where people can be insured on these things. Or we just have to, we backstop up to a certain amount or a certain level based on the amount of money that's being spread out. So I think there is trust in terms of we can guarantee that someone can't run off with the money in the sense that like they were the ones trusted to control all of it. But if they're the ones who receive like a peer-to-peer loan and then they run away, and then you trusted someone that you didn't know, that you didn't have any relationship with, and they're just an avatar on the internet, then like I think probably the thing that we have to do is provide within the social layer of the application ways to like verify who someone is and like provide that trust there.
So you said something about a pilot in Nigeria and things like this, but I guess what is always on my mind is how do you bridge this like DeFi money into like real world money, I guess, in a way. Like if persons in a village somewhere want to participate in this, what's their incentive? How are they gonna use that outside of the internet, I guess?
Yeah. I mean, that's why kind of right now we're largely focused on like digital services, like things that people can purchase online. So anything that is online can be purchased, with crypto one way or another. The other option is we can, just wait for like what are the things that are coming out, hopefully, like over the next few years. So it's also a bet that like it'll get better, and that it'll, it's like either, of course, if they're in a place where they have no access to ways of offboarding, then it's not a good market to work in, I think. But the bet is that in a lot of places it's going to improve, and you will be able to kind of convert by paying either digitally or with a card of some sorts, that you will be able to do that. But if you have no internet access and you have, everything is purely in cash, then of course it's going to be really hard, yeah. Cool. All right, thanks so much. Appreciate it. There's a Telegram group again in case you wanted to join it.
Hello? Hello? Okay, hello guys, hello. So, how's everyone? Everyone doing good? Okay, so good afternoon guys. Okay, before I start my presentation, I want to first introduce myself. I'm Michael, one of WalletBeat's contributors. If you've seen me on X, you've probably seen me posting as MatMat. Okay, so let's talk about Ethereum wallets. First, I want to ask two questions. Who here has used an Ethereum wallet before? Okay, so it looks like almost everyone here has used an Ethereum wallet before. And now my second question is, who here has signed a transaction before fully understanding what it does? Okay, I see. There's still a few hands. That's nice. So I'll be the first one to admit it. I have signed more than one transaction without fully understanding what it does. I know it's kind of embarrassing, but transactions such as Uniswap transaction or CowSwap transactions, I think it's quite common in our space, right? Most of us here has used an Ethereum wallet before, so that's exactly why wallets matter. And other reasons why wallets matter is that number one, it holds your keys. Two, it holds your funds. And three, it enables you to sign transactions. So with all of that being said, your wallet should at least be secure, right? I want to ask you guys, what wallets are you using? Please raise your hand if you're using Ambire. Any Ambire users here? Okay, I see a few. How about MetaMask? Okay, MetaMask. It's the most popular. How about Rainbow or Rabi? Okay, I see. Safe? Okay, so with all of that being said, these are all great wallets. They have been battle tested, and these are the wallets we've known throughout the years. But here's the thing. It doesn't matter if you have the most secure wallet if you don't know what you're signing. Well, you guys remember the Bybit hack? $1.5 billion got stolen from Bybit. It was not a vulnerability exploit. It was not a smart contract exploit. But it was a result of blind signing. Now, this is not an attack on Bybit or any of these protocols, but because the current wallet landscape makes it difficult for users to understand and verify what they're assigning. I think we have a transaction legibility problem. Now, what is the transaction legibility problem? Users do not actually know what they are signing. Users experience things like horrible raw call data experience, which leads to poor hardware wallet transaction verification, and then users would just YOLO sign or blind sign. Now, luckily for us, this is where ERC 7730 and ERC 8213 comes in. ERC 7730 helps you understand what you sign. On the left side here, we have the raw call data. This is a Aave supply transaction. And on the right side, this is the human-readable transaction that ERC 7730 provides. Users need and want the one on the right and not the ugly thing here on the left, right? But the way ERC 7730 works is that for whenever a project or a smart contract developer deploys a contract, you would need to register it to a registry, which is right now kind of a centralized registry. It's a GitHub repository. Funny story about this is I was actually planning on deploying my own contract and showing how ERC 7730 implementation works. But looking at how many PRs are still not merged just for project registry, then I might as well not. But the key thing is, if your project is not registered in the registry, means no ERC 7730 implementation. And this is where ERC 8213 comes in. ERC 8213 provides the call data digest that you can see on the right, which is much easier to verify than the 330 character count, which is the same Aave supply transaction we have earlier. I would still consider this as a short call data. Imagine if you're signing things like Uniswap or even safe transactions, then you will probably appreciate the byte32 digest, right? ERC 7730 helps you understand what you are signing, and ERC 8213 helps you verify what you are signing. The key message is this: wallet user experience and wallet security are increasingly becoming problems of standardizations. But what if more wallets start to adopt both standards? What do we get? We get better wallet interoperability, better wallet transaction clarity, better user trust, and better wallet safety, and also better open competition. Almost better everything. Now, the question to ask is, what wallets adopt these standards? What wallets implement certain EIPs or certain ERCs? What wallet provides basic user safety or user privacy? And this is where WalletBeat comes in. So, WalletBeat is a wallet rating system for Ethereum wallets. We are the L2Beat of wallets, and we evaluate wallets based on 5 dimensions: security, transparency, privacy, ecosystem alignment, and self-sovereignty. WalletBeat aims to raise the bar and push the wallet ecosystem forward. Now, one of our most recent implementations is now that we're tracking ERC 7730 and ERC 8213, or the wallets that implement them. And alongside with this is we've built a WalletBeat testing playground, which you guys will be playing around in a while. I'll be demoing it to you right now. So, to go to the WalletBeat testing playground, first you have to go to the WalletBeat page. It's beta.walletbeat.eth.limo. I know it's a handful. And then afterwards, you navigate to the sidebar, test your wallet. And then before you do anything, you must connect your wallet. But please take note that you should just use the seed phrase that we've given you. WalletBeat won't be responsible for any losses or any drains. Okay, so now I'll be doing the demo. Okay. I'll connect my wallet first, of course. Okay, so we have multiple tabs here, but we'll be focusing mostly on transaction simulations and scam alerts. So we have transactions, signatures, EIP support, app isolation, transaction simulations, scam alerts, and our most recent tab, ERC 8213, which helps you calculate your call data digest, and EIP 712. Okay. So what I love about MetaMask is that they handle transaction simulations properly. Let me show you what I mean. Here we have a volatile outcome transaction. And not only does MetaMask simulates a transaction for you, but after a while or after a few seconds, it resimulates a transaction again. As you can see, MetaMask shows you that you'll be sending 100 tokens, but after a few seconds, hopefully it shows, there you go. It shows you that instead of sending tokens, you'll be receiving tokens. And checking out your wallet's transaction simulated feature is very important, especially when it comes to transactions that depends highly on variables that are always changing. So scammers could utilize these kinds of transactions by creating a D app and then letting wallets only simulate a certain block number and will show you what looks like a perfectly normal transaction. Then during the execution, would execute the malicious state. So let's move forward to one of the other tabs, scam alerts. What I also love about MetaMask is that whenever you're trying to sign an unlimited approval, it shows you a warning. So it's already 2026, right? So unlimited approval is not required anymore. Please ask your wallets to have batch transactions to remove this necessity. And then one last tab I want to show you guys is EIP support. So this tab essentially tries to scan your wallet if what EIPs do they support. It's quite straightforward. You just have to run through 6 different steps. I'll show you guys. So run step. And on the 5th step, it will ask you to sign a transaction. Let's just assume that this transaction pushes through. And then afterwards, it will show you that a test result of what the test has gone through. It will either show you a passing rate or a partial rate and a failing rate. So a partial rate means a wallet implements all required and optional features of the certain EIPs. For example, this one, EIP 6963 and EIP 1193, the wallet implements all required and optional. And for a partial rate, it means a wallet implements all the required features of the EIP, but not all optional features of the EIP, and that's okay. And for the failing rate, it means that the wallet does not implement all the required feature of the EAP. WalletBeat only cares about wallets implementing or wallets having a passing or a partial rate. So now, please feel free to work around with the WalletBeat testing playground. Polymutex will be distributing sheets of paper that has a seed phrase in it, and we've prepared a little activity for you. Yeah. Hello.
Hi, thanks for the great introduction.
Uh-huh.
You said instead of unlimited approval, just ask wallets to do batch transactions. Can you
Yes.
explain why that solves the issue? So if I want to give approval so that I don't have to, every time I go on CowSwap, approve a specific amount, usually I just do unlimited approval, and in the future it will just accept my USDC without asking again.
Well, yes. I think part of why unlimited approvals was accepted in the first place was because we were forced to have two different transactions. Before it was approve and swap for Uniswap, correct? But now, through batch transactions, we remove that friction of having to approve two transactions by batching them into one transaction.
Ah, okay, that's what you meant. Okay, thanks.
Any other questions? Okay, so again, guys, feel free to play around with the wallets, and we'll be back after 10 minutes. So I'll be here to roam around and assist you guys as well. One for. There you go. You guys need any help?
Yeah, I'm going around the playground and I see here a lot of example transactions that I can send. Oh, maybe the point here is that the way you see it on the
Exactly.
wallet.
Yeah. See how it reacts and any comments, any feedbacks.
There's a fee.
Oh yeah, I think that's because you don't have any USDC, so feel free to swap. The 5, I think 0.005 ETH is all yours. Feel free to play around with it, do swaps, anything you want. Do you need anything here? Do you need any help? Play around with the wallet. Okay, so also visit the wallet beat testing playground. And then just check how your wallets react to different certain scenarios or situations. And hello?
Hello.
You need any help?
So far, so good.
Okay, so.
So I loaded one wallet. Okay, what's the next step?
Just play around with the wallet actually. That's the whole point of the wallet beat testing playground. So I'll.
Okay. Sorry, I did it on a fresh wallet.
Yeah.
You wanted me to do it within wallet beat.
Or any application that you want.
Okay, so I use Brave Wallet.
Okay, did you import the keys?
Yes.
And does it show that you have tokens?
No.
Okay, so question is why? Can you try the other one?
Yeah, but usually you can have, it gives you a lot of addresses. So maybe it's not detecting the right address where there is one, no?
Well,
so for example, with the seed on MetaMask, if I load my seed on MetaMask, the first default address it will give me might not be the one that I actually use.
okay, yeah, but did you use this set or?
Yeah, exactly.
Okay.
No.
Is this mic available?
Oh, thank you. Yeah, usually I'm just solution part. So this time I want to give a bit more narrative. So the best solution is you are This is one way of saying it. Thank you.
Hello, 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 hello. Hello, guys. Hope you guys had a lot of fun exploring your wallet, exploring the wallet beat testing playground. But for now, let's take a look at the screen again. Okay, so we've discussed earlier both standards ERC7730 and ERC8213 and how it helps the whole user signing experience. But what does it really look like in real life? So I'll be doing demo on how it would look like, okay? So context on the transactions I'll be doing is that I'll be doing an AAV supply transaction through safe multisigs. And I'll be comparing 3 wallets. One wallet that does not implement both ERC7730 and ERC8213. And another one, a wallet that implements ERC7730, and a hardware wallet that implements ERC8213, and see how it really improves the whole user signing experience. Okay, so for the first transaction, I'll be using Phantom. Phantom has 5 million users for I don't know what reasons, actually, because you can see in a while what I mean. Oops, not Amber. Okay, so this is the same transaction using now Phantom. Okay, so not only it fails to simulate the transaction, but also it provides 0 data at all. We can see here in the raw call data, we can see here in the transaction details, it only provides the raw call data, which users have no idea what they're gonna sign, or it will be even almost impossible to verify. But now let's compare it with the wallet that implements ERC7730 or human readable transactions. Okay, so as we can see here, it's now more understandable and it's now more easier to verify, correct? So it says here that you're executing a safe wallet transaction, but not only it decodes the safe transaction, but it also shows you that you're going to be doing a supply transaction on Aave. So this is what users need and this is what users want. And now let's take it a step further and let's try to verify it on a hardware wallet. Unfortunately for us, we still don't have any hardware wallet that, or sorry, a software wallet that implements ERC8213, but let's just use our imagination for in the meantime. Let's calculate our own ERC8213 digest. This is still the same transaction that I will be signing, the same transaction earlier. It might take me a while. Okay. Okay, now I'm computing our own call data digest since Amber doesn't have one. Let's just imagine that this call data digest we have here is implemented in the Amber itself. And now I need someone from the audience to help me verify itself. Any volunteers, please? Any volunteers to help me verify this transaction? It will be easier, I promise. You? Okay. Okay, nice. What's your name, by the way?
My name is Sebastian.
Sorry?
Hello, my name is Sebastian.
Okay, please give a round of applause for Rasha.
Nice
Okay,
meeting you.
Mike, nice meeting you again. Okay, so have you used a hardware wallet before?
I might.
I might. You haven't. Okay, so I might convert you. Okay, I'll just scan this QR code here. Okay, so the way verifying transactions on a hardware wallet works, normally users would look at this call data and verify it every character. So you can just imagine how tedious and almost impossible this process is, correct?
It doesn't look like fun, actually.
Yeah, exactly, right? So, and again, this is still a short call data. So imagine a longer call data, right? Almost impossible. So with the help of ERC8213, which is this thing right here, is this better?
This is way better, actually.
Yeah, okay, so can you dictate character by character?
Yeah, I would be able to do it.
Let's do it. Okay. I'll place it here.
Should I read it?
Yeah, sure.
Okay. So it's 0x0FD57BCA 0E23 2B DD84A9. So it continues for a while now, I think so.
It's okay, it's okay. Okay, so the whole, you can continue.
Once again?
Yeah, you can continue from A9.
It should continue, okay.
Yeah,
7B 187041 F9F19. So I think it's yeah. Should I continue till the end, or
Yeah, sure,
is this
sure,
the goal?
let's continue
Okay,
till the
okay, like guys. So listen to me reading numbers and
Sure,
letters today.
we have all the time.
9F19 D1 CA 5639 EA5 75 CC 1 EE 6 CFC 693 0 BB4.
Okay.
I made it.
Okay, thank you again. What's your name again?
Sebastian.
Okay, thank you, Sebastian. So, while it might look tedious, the way we have it normally works is that before ERC8213, we have to verify pages of call data. So, this is what we have now. And as you can see, the byte32 digest is a much, much bigger improvement from what we have originally. Okay, so going back, standards like ERC7730 and ERC8213 aims to improve user experience and interoperability. But again, standards will be useless if not widely adopted. And as part of the ecosystem, WalletBeat will be playing its role to push wallets toward better standards, better interoperability, and safer user experience. And if you like this workshop, please feel free to follow us on our socials and give us a shout out. And thank you guys. Okay.
Thanks. Because we didn't get that far on here, but did you show before that there is a button I can press if my wallet does not have it, that it automatically sends a message to the wallet?
Sorry?
Like, I thought before you were showing something where if the feature or like they've not implemented any of these standards, there was something on your website that would allow me to send a message to the wallet and make them aware of that gap, or did
Well,
I imagine
no,
that?
I think what you're talking about is the call data digest that we calculated through the WalletBeat testing page. Is that it?
Sorry, say that again?
Yeah, so
Okay.
yeah, I think that's it. No, I'm just trying to show the possibilities of what it would look like if a certain wallet implements the standard, the call data digest, in which for now we have to improvise.
Okay, but if I find out that my wallet does not do any of that through your tools, and you say like make sure that your wallet does have these features, I have to contact them, or what's your call to action?
Well, that's exactly the mission of WalletBeat, is to making these wallets care, especially for these standards and values. So we would like your support to rally around these standards.
Okay.
Okay.
I'm afraid that's all the time we have for today, so thank you once more for our speaker.